Hi children, how are you? So today we are going to learn the numericals part of this lesson. Already you have learned about the theoretical part. Now we will continue with the numerical part of this lesson. Understand? First one. A car is at a distance of 400 meters from the signal lights. It is moving towards the signal. Okay. Then he observed a red color on the signal. So it's applied the brakes. When he applied the brakes, it starts decreasing the speed. That means deceleration or negative acceleration. So we'll see the sum first. Okay. Say car is moving towards the signal light, applying the brakes. It stopped before the signal. Okay. Our question is the distance is L, let it be 400 meters. Okay, he applied the brakes. Initially the car is moving with 54 kmph before applying the brakes. Then he starts applying the brakes. It stops after some time. We don't know the time, we have to calculate. Okay, and after 1 minute, what may be the position of the car from the signal light, that we have to find out. So first of all we have to find out the time and also position of the car. Okay, so let us do how to do it first of all. Right, the solution. What is the initial speed of the car? It is 54 kmph. Okay, when you want to convert the kilometer per hour into meter per second, what you have to do is you have to multiply with a fraction, that is 5 by 18. How you got 5 by 18? Means kilometers per meter is 1000 and time is hour per second is hours in seconds are 3600. So 1000 by 3600, you will get 5 by 18. So you have to multiply with a factor 5 by 18 to convert the kilometer per hour into meter per second. So here it is equal to 15 meter per second. Now that is initial speed. Okay. Why? Because all the quantities should be in same units. Okay, one should not be in kilometer per hour, another one should not be meter per second. We have to convert all into the same. Okay, because acceleration is in meter per second square. Okay, so here after applying the brakes, that means car is going to come to rest. That means by final velocity is 0. Good. Next, acceleration or negative acceleration, because applying the brakes, that is minus 0.3 meter per second square. Okay, first of all we will calculate the time, how much time it takes. That means what is the first equation of motion? V is equal to u plus at, then t is equal to v minus u by a. Already you learned all these things, isn't it? First simply you have to remember those formulas, right? Substitute the values. Okay, here v is equal to 0, u is equal to 15, then minus 15 by minus 0.3 will give you 50 seconds. That means what we have to do, we have to calculate after 1 minute what is the position. Already 50 seconds it come to rest. Okay, that means before only it comes to rest here. Then what we have to calculate now, what is the distance between the car and the signal point. Okay, the car and the signal point, it stops there. So what we have to calculate, the distance traveled by the car from its initial point to the final point, or initial position to the final position. If you calculate the distance, you can subtract the total. So you can subtract from the total distance and you will get the what is the position of the car after 1 minute. Okay, so here taking this equation of motion, v square minus u square equal to 2as, this formula should be used when there is no time. Okay, so s you have to calculate. So here s is equal to u minus u square by 2a. Understand? Minus u square by 2a. Substitute the values, then what you will get, it is equal to 375 meters. So before reaching the red signal, it stops 375 meters only. That means total distance is 400, and distance covered by the car is 375. So it stops before 25 meters, isn't it? So after 1 minute, when there is no green light, the car will be at a position 25 meters from the signal light. Okay, that is the answer. Understand? So a car applied the brakes with which is moving with a initial velocity, applied the brakes, that means negative acceleration, at a 400 meters distance. It stops after come to rest. Okay, it stops after some traveling some distance. That distance we have to calculate. If you know that position, you can calculate the position of the car from the signal light. Okay, understood? Good. Now we will do another one. So here a object or any object or a car or a ball which is moving with which is started from rest and picked up some speed and reaches a velocity v. Okay, at the midpoint, what is the velocity that we have to calculate? Okay, what is the speed of the body moving with a uniform acceleration at the midpoint of 2 points on a straight line where the speeds are u and v. So initial velocity is u, final velocity is v. What is the speed at midpoint? Don't think that it is simple average, that means u plus v by 2, not that. Okay, you have to calculate the average speed or speed at, not average speed, speed at the midpoint you have to calculate. Okay, at the midpoint, that is, let it be v0. At the midpoint the speed is v0, initial speed is u, and final velocity is v, midpoint v0. That means we have to take two cases, one from the starting to the midpoint, another one from the midpoint to the ending. So two cases we have to take, then you can easily calculate. Okay, so first case from the initial to the midpoint, second case from the midpoint to the end point. Okay, how to calculate? Normal, already you have learned, you have seen that it is moving with a constant acceleration, let it be a. So distance covered it is s. Okay, now from the equation of motion, which formula you have to take, you will get a doubt first of all. Three equations are there, sir, which formula you have to take, you will get. So there time is not given, so there should not be any t. So what remains is v square minus u square is equal to 2as. Okay, that formula you have to take. So you have to take it two cases. First one, initial velocity u, final velocity v0. Substitute that. Okay, second case, initial velocity is v0 and final velocity is v. See, let us see here. Okay, that is two cases, applying those, then comparing those two equations by mathematical equations or rearrangement of the terms. Then what we actually we want to calculate, v0 you have to calculate. So take the v0 as a subject, then what you will get is v0 is equal to root over v square plus u square by 2, or square rooting on both sides, like that you have to do it. Okay, rearrange the terms and take the subject as v0. Understand? Good. Just once revise. Okay, two cases. First of all, here you have to see the two cases. First case, from the initial to the midpoint u and v0, from the midpoint to the final v0 and v. Substitute those u v values in the two cases, that same equation. Okay, then take the v0 as a subject on both sides, then compare 1 and 2. Then what we will get is v0 is equal to root over v square plus u square by 2. Good. In this case, we will take one a special one. Acceleration is one direction, and velocity is another direction. Let us see what is that. Okay, the question is, an object is moving with a constant acceleration 2 meter per second square in west direction. Okay, west. Okay, and moving with the velocity, initial velocity 9 meter per second in east. That means a car or an object going to stop and come back again, because acceleration is in opposite direction. So here what we have to calculate is the distance covered in fifth second. In the last second we don't know how much distance it goes in the forward direction and how much distance it takes in traveled in the opposite direction, we don't know. So first of all we have to calculate the time. So here an object is goes to one position, again it comes back and comes to rest. Okay. So what we have to calculate, a distance is traveled in the last second or fifth second we have to calculate. First of all we have to calculate the time. So acceleration is in the opposite direction, west direction, and speed is in the east direction. So how to do it? U means initial velocity 9 meter per second, acceleration 2 meter per second square. You have to see the three equations of motion. The first equation, what is given, u and a are given, you have to find out t, and okay, then simply t is equal to v minus u by a. Okay, then substitute those values in the equation. Okay, so here v finally it comes to rest and comes back, no? Then v is equal to 0, then 0 minus 9 by minus 2, and what you will get is t is equal to 4.5 seconds. Okay, that means it traveled for a time of 4.5 seconds and comes back again, isn't it? But what is we have to calculate in the fifth second, we have to calculate. That means if you know half of the second how much distance is covered, then you can calculate the last second, isn't it? So we here we will calculate for half second. Okay, distance covered in half second. That means 4 to 5 you have to calculate. So in between 4 to 5 how much distance is covered in between half second. If you calculate, you can take the same as it is, because it is coming back with the same speed acceleration, isn't it? So here distance covered, so s is equal to ut plus half at square. For half second you have to calculate. Okay, u initial, okay, from coming back, okay, then it is initially it is 0, and half at square means half into a is acceleration is 2 and time is half, and then what you will get is distance is 1 by 4 meters. So if for half second it is 1 by meters, for 1 second that means into 2, that is half meter. So 1 by 2 meters is the distance traveled in the fifth second. Understand? Good. We will see one more case. A stone or an object is dropped into a well. Okay, it touches the water and gives a sound. Based on the sound, okay, time of the sound, okay, you have to calculate the speed of the stone before touching the surface, water surface. Okay, let us see what is the sum. So before touching the water surface, what is the speed of the stone, you have to calculate. So a stone is dropped from the top of the well. When it is dropped means freely falling body. What is the initial velocity of the freely falling body? Always 0, remember. Okay, then it reaches the surface after 2 seconds. Find the velocity of the stone when it touches the surface of the water. then that also you have to calculate, and also you have to calculate the depth of the water surface, okay, from the top of the well. So two cases you have to see. Okay. First one, let the time be 2 seconds. Okay, it is freely falling body. That means its acceleration is always equal to the acceleration due to gravity. So g of the earth, okay, at any place is 9.8 meter per second square, but here it is he asked to take it as 10 meter per second square. Okay, g is equal to always 9.8 meter per second square, that is acceleration due to gravity, small g, not capital G. You will learn about capital G later. Okay, so u is equal to initial velocity of the freely falling body 0, yes, 0 meter per second. So again we will use the first equation of motion, v is equal to u plus at. So calculate the velocity. Okay, time is given, initial velocity is there, calculate the final velocity. Then let the depth be s. So here we have to calculate the depth of the water, okay, isn't it? So s is equal to ut plus half gt square. Then applying the values, what you will get is 20 meters. 20 meters. Okay. So u is initial velocity is 0, time is 2 seconds, and half into g plus 10, and t square 2 into 2. Okay, then 2 get cancelled. What you will get is 2 into 10, that is 20 meters. So what is the depth of the water surface? 20 meters. After what time you are able to hear the sound? 2 seconds. Okay, for touching the surface, what is the speed of the stone? Yes, it is how much? 20 meter per second. Good. Here one more important concept, okay, and also very interesting concept also, because all your people are very fond of to travel in trains, cars and aeroplanes, isn't it? So this is a sum which is related with your interest. Okay, a train moving on a bridge. Okay, a train of length, what is the length of the train? 50 meters with a constant speed, that is 10 meter per second. So what we have to calculate, a train time taken to cross the electrical pole, first case, and time taken to cross the bridge. When you are taking the electrical pole or a reference point, simply you can calculate the time by using, what is the speed formula? Speed is equal to distance by time, isn't it? Then time is equal to, yes, time is equal to, speed is equal to distance by time, time is equal to distance by speed, isn't it? So we'll use that formula and we'll easily calculate. Okay, but second case, it's an interesting one, I will tell you. Okay, the further solution. Length of the train 50 meter per second, speed of the train 10 meter per second. To cross the electrical point, simply time is equal to distance by speed. Then t is equal to, distance means, what is the distance? The length of the train. Okay, the reference point is electrical pole. Okay, then distance is 50 and speed of the train is 10. Then to cross electrical pole, it takes 5 seconds. Then what is the length of the bridge? 250. Remember here in the second case, the train has to cross the bridge. That means bridge, initial point, final point. Initially the engine will touches the bridge, and finally the guard will end the bridge. That means you have to take the total length of the train plus the length of the bridge. Okay, that means total length is 250 plus 50, that is 300. Okay, now that total length by the speed, or distance by speed. The distance is total length of the train before touching the bridge and guard after coming out of the bridge. The total length you have to take. Okay, that we can take this as a time. Okay, the time you have to calculate. Time is equal total length is 250 plus meet 50 and speed is 10, so it is 30 seconds. Actually, this is very easy to understand, and but which is very important to learn also for you. Okay, learn once or twice. Okay, referring the videos, and I am giving you some other material also. Okay, understood? So two cases you have to calculate. First one, reference point electrical pole. Second one, total length by the speed. Understand? Right. Here one more logical sequence. A car, half of the distance is moving with one speed, another half of the distance with another speed. Then what is the average speed? That here you have to calculate. See, here I am teaching you only the concepts which are very logical. Okay. So here a car covers half of the distance at a speed 50 km per hour and other half at 40 km per hour. Find the average speed. Normally average means you will simply take 50 plus 40 by 2, 45. It is not correct procedure. Okay. So here how to calculate? Say car is moving with half distance one speed, another half distance with another speed. Then what is the average speed of that car? Okay. So here again we have to use the speed formula. Speed is equal to distance by time. Okay. So here let the total distance be x. Total distance from the initial point to the final point. That means speed in the first half, it is given that it is equal to 50 kmph. Okay. Speed in the second half, what is given? 40 kmph. Okay. Let the total time case 1 t1, case 2 t2. Then time is equal to, what is the formula? Distance by speed. Yes. Time is equal to distance by speed. In the first half means x by 2 distance. Speed is 50. So that is equal to x by 100. In the second half, distance is x by 2. Speed is 40. So x by 2 by 40. That is x by 80. Normally, what is the formula here you used? Time is equal to distance by speed. Then total time, you have to add those two fractions using LCM. Okay, 10 and 180, LCM is 400. Okay, by doing the LCM, a mathematical method, what you will get is 9x by 100 after simplification. Okay, so that LCM we calculate. Okay, 180, that is okay, 400 is the LCM. Like that you will get it is equal to 9x by 100. Okay, average speed formula already you learned in the previous classes, isn't it? Total distance by total time. Yes. What is the average speed? Yes, total distance by total time. Total distance x and total time taken 9x by 100. X get cancelled. What you will get? It is equal to 44.44. Understand? I hope you have understood well, isn't it? Good. Okay, and these are my details. don't hesitate to ask the doubts. Okay, and you can send the email or you can contact. Understand? Hope you understood well, and thank you. Bye.